Concentration measurement. Okay, the first one, let's look at molarity. For molarity, you must know the formula, and also you must know it is mole of solute over volume of solution. So when you read this type of question, you must identify which is solute, which is solution. For molarity, we can use capital M. But if let's say the question asks calculate concentration, then you must use the symbol C. The unit is still the same, that is molar, capital M, or mole per dm cube. And in your exam, remember the final answer you must give units and also the formula. Next one, molality. For molality, it is very important that you must give the formula mole of solute per mass of solvent, and you must label kg. So for this part, from this question, you must able to identify mole mass of solute so that you can get mole of solutes, and then you must identify what is the solvent. Solvent and solution are not the same thing. Then our solvent usually is H2O. Molality, the unit is mole per kg or small m. Small m stands for molar, capital M stands for molar, okay, for molarity use. Okay, another one, we come to mole fraction. Okay, for mole fraction, we use the symbol X. Okay, it's not necessarily mole of solute. It depends on the question itself. Okay, in this question, it has ethanol and also water. Means that we have two things, that is ethanol and water. So if let's say the mole fraction, when they add up together, they must be equals to 1. Okay, so therefore, we calculate one of the mole fraction. Then, for example, ethanol, and then the other one, that is water, we just use 1 minus 0.215, because when they add up together, they become 1. Okay, percentage by mass. Okay, when we look at percentage by mass, we must know that it is mass of solute over mass of solution. Okay, so you must know how to calculate. Okay, so in this case, mass of solution is, must remember, mass of solute plus mass of solvent. Next one, percentage by volume. Okay, it's the same, volume of solute over volume of solution. Now, this kind of question, sample exercise 17, it combines a lot. That is, it combines density, concentration, and molality. Okay, so how to find this kind of answer? Okay, first of all, always identify which is the solute, which is the solvent, which is the solution. Then if let's say you want concentration, then you know that, then you write down the formula, concentration. Then if you are looking for molality, same thing, write down the formula. Then you will know which information, solute, solvents that you need to use. Okay, another one that I want to highlight is density. Okay, density can help us to find the volume of solution or mass of solution. Next one, let's look at this. Okay, this is the one that I want to highlight, that's the percentage by mass. What is the meaning of 10% of HCl by mass? So remember, means that 10% will be solute, then 100% is solution, leftover will be solvent. So from the percentage by mass here, you can assume mass of solution equals to 100 gram. Okay, then the rest you can do it on your own. Okay, now let's look at this. This also uses density, okay, and then it already gives you the volume of the solution. So in this case, you must use the volume of solution given. Okay, summary. You must be able to differentiate between solution, solute, and solvent clearly. Molarity, the symbol is M. Concentration, the symbol is C. Okay, then I want to highlight something on volume of solution. Okay, let's say the concentration is 2.0. Then you can assume the mass of solution, okay, for example, 2.0 gram per cm cube. Then you can assume that you have 1000 cm cube, okay? Or, okay, if you have 1000 cm cube, then your mass of solution, you will have to have 2000 gram of solution. Okay, if you don't want a big figure, then you can use 1 cm cube, 2 gram of mass of solution. Okay, why do I use 1000 gram? Okay, because remember, in concentration, we use dm cube. Means that 1 dm cube equals to 1000 cm cube. Okay, so if you want to assume 1000 or 1 cm cube, make sure you write down assume volume of solution equals to 1 cm cube. Okay, however, if the question already gives the volume of solution, then you can no longer assume the volume of solution. Okay, so that's all for summary for concentration and measurement.